Hi everyone. Today we're going to study Introduction to Quadratic Equations. A quadratic equation in the variable x is an equation of the form ax squared plus bx plus c equals 0, where a, b, and c are real numbers, and a, which is the coefficient of x squared, is not equal to 0. Examples: 2x squared plus x minus 300 equals 0. 3x squared minus 3x equals 1. 4x equals x squared minus 1. X minus x squared minus 1 equals 0. In fact, any equation of the form p of x equals 0, where p of x is a polynomial of degree 2, is a quadratic equation. But when we write the terms of p of x in descending order of their degrees, then we get the standard form of the quadratic equation, and that is ax squared plus bx plus c equals 0. Again, we say that a is not equal to 0. Example 1. Represent mathematically. John and Giovanni together have 45 marbles. Both of them lost 5 marbles each, and the product of the number of marbles they now have is 124. We would like to find out how many marbles they had to start with. We let x be the number of John's marbles. In that case, 45 minus x is the number of Giovanni's marbles. In the condition, it says both of them lost 5 marbles. So for John, it will be x minus 5. While for Giovanni, we will have this 45 minus x, then minus 5. We can simplify this into 40 minus x. In the given, it says the product now is 124 for their new number of marbles. So we represent this as x minus 5 times 40 minus x equals 124. Let us multiply this binomial by this binomial. So it becomes 40x minus x squared minus 200 plus 5x. And this 124 on the right, we transpose to the left. It becomes negative 124. And the right side becomes 0. We now remove the grouping symbol and we combine like terms. We write first the negative x squared, then we combine 40x by 5x becomes 45x. This negative 200 combined with negative 124, that is negative 324 equals 0. We can make this negative sign of x squared to be positive. Let's multiply this equation by negative 1. So we have now x squared minus 45x plus 324 equals 0. This is now our answer. Example 2. Represent the problem mathematically. A cottage industry produces a certain number of toys in a day. The cost of production of each toy in rupees was found to be 55 minus the number of toys produced in a day. On a particular day, the total cost of production was 750. We let x to be the number of toys produced on that day, meaning 55 minus x is the cost of production of each toy. Then, the total cost of production on that day is x times 55 minus x equals 750. We multiply this x by 55 minus x. Then the 750 we transpose to the left side. So it becomes 55x minus x squared. Then negative 750 equals 0. Let us multiply this by negative 1 and we will rearrange. So it becomes x squared minus 55x plus 750 equals 0. This is now the answer. Example 3. Check whether the square of x minus 2 then plus 1 equals 2x minus 3 is quadratic. If the equation is quadratic, then it can be simplified into this form. So let us simplify the equation. Let us simplify the square of x minus 2. Remember our special product, the x minus y, that is squared, equals x squared minus 2xy plus y squared. So the square of x minus 2 becomes x squared minus 4x plus 4, then plus 1 equals the right side. We remove the grouping symbol, and then the right side values we transpose to the left. So it becomes negative 2x plus 3, then equals 0 for the right side. We combine like terms. We start with, we copy this x squared down. We combine negative 4x by negative 2x, becomes negative 6x. Then the constants 4 plus 1 plus 3 becomes 8 equals 0. Since the simplified equation is of the form ax squared plus bx plus c equals 0, then it is a quadratic equation. Example 4. Check whether x times the quantity x plus 1 then plus 8 equals x plus 2 times x minus 2 is quadratic. If the equation is quadratic, then it can be simplified into this form. So let us simplify the equation. We multiply this x to the binomial here. Then on the right side, we will remember our special product that says x plus y times x minus y equals x squared minus y squared. Let us now simplify the equation. The left side becomes x squared plus x, then this plus 8 equals the right side becomes x squared minus 4. We transpose all terms of the right to the left. So this x squared becomes negative and this negative 4 becomes positive. Now the right side equals 0. Let us now combine like terms. We have here x squared and negative x squared that cancels each other. Then we copy this x down, and 8 plus 4 is positive 12 equals 0. Since the simplified equation is not of this form, then it is not a quadratic equation. In fact, we call this linear equation. Example 5. Check whether the cube of x plus 2 equals x cubed minus 4 is quadratic. If this equation is quadratic, then it can be simplified into this form. Let us now simplify the equation. On the left side, let us first remember our special product that says the cube of x plus y equals x cubed plus 3x squared y plus 3xy squared plus y cubed. We apply this on the left side of the equation. So the left side becomes x cubed plus 6x squared plus 12x plus 8 equals the right side values. Let us now transpose the values of the right to the left. So this x cubed becomes negative, and this negative 4 becomes positive. Now the right side equals 0. Let us now combine like terms. X cubed, then negative x cubed will cancel out. Then we copy this 6x squared plus 12x, then 8 plus 4 is 12 equals 0. We can simplify this further by dividing by 6. So we have x squared plus 2x plus 2 equals 0. Since the simplified equation is of the form ax squared plus bx plus c equals 0, then it is a quadratic equation. Hi everyone, today we're going to study solution of a quadratic equation by factorization. A real number alpha is called a root or solution of the quadratic equation ax squared plus bx plus c equals 0, where a is not equal to 0. If a times alpha squared plus b times alpha plus c equals 0. We also say that alpha satisfies the quadratic equation. Note that the zeros of the quadratic polynomial ax squared plus bx plus c and the roots of the quadratic equation ax squared plus bx plus c equals 0 are the same. A quadratic polynomial can have at most 2 zeros. So, any quadratic equation can have at most 2 roots. To solve quadratic equation p of x equals 0 by factorization, factorize the p of x. Equate each factor to 0, then solve for x for each of the factor. Example 1. Find the roots of the equation 2x squared minus 5x plus 3 equals 0 by factorization. We factorize this by splitting the middle term. In some books, they call this AC method. Take note that our form here is the ax squared plus bx plus c equals 0, where a equals 2, that is the coefficient of x squared. The b is the coefficient of x, that is negative 5. C is the constant 3. The first step here is to multiply the a and the c. That is 2 times 3, and the product is 6. Next, we list all factor pairs of 6. Now, take note, since AC, that is the number 6, is positive, it means the factors must have same sign, and the common sign is similar to sign of B. In this case, it is negative. Therefore, the factor pairs of 6 are negative 1 times negative 6. This is the first pair. Second pair, negative 2 times negative 3. Then we get the sum of the factors, negative 7, negative 5. Then we look for the value of B as negative 5 in this column. We can see that negative 5 is here. So it points to the factor pair negative 2 and negative 3. Now, we rewrite our original equation. This time, we will split the middle term using this factor pair. So we have 2x squared. Now look at the negative 5x. It becomes negative 2x and negative 3x. Then we copy the constant plus 3 equals 0. From here, we will factor by grouping. In here, we group the first two terms and we group the last two terms. For each of the group, we factor out the greatest common factor. Factoring out the GCF, which is 2x, in the first group, what remains is the x minus 1. In the second group, the GCF is negative 3. So what remains inside is x minus 1. Now, for the two groups, there is a common factor again. That is the binomial x minus 1. Let's factor it out. So it becomes like this. In the first group, what remains is the 2x. In the second group, what remains is the negative 3. These are now the factors of the 2x squared minus 5x plus 3. Then let us equate each factor to 0 and solve for x. So x minus 1 equals 0, 2x minus 3 equals 0. In the first equation here, we transpose negative 1 to the right. So x equals 1. In the second group, we transpose negative 3 to the right. Then we divide the equation by 2. So x equals 3 over 2. These are the values of the x, or we call this root or solutions. If we want to check if these values are correct, we substitute these values to the original equation, and you will find out that this will be satisfied. Example 2. Find the roots of the equation x squared minus 3x minus 10 equals 0 by factorization. The factors of the trinomial on the left side will be like this: x plus m times x plus n equals that 0 on the right. Now let us find m and n. Take note that the product m times n should be equal to the negative 10, the constant, and the sum m plus n must be equal to the negative 3, which is the coefficient of x. Take note that the constant negative 10 being negative means m and n must have opposite signs. Let us list all factor pairs of negative 10. These are the pairs, starting with 1 times negative 10, negative 1 times 10, 2 times negative 5, negative 2 times 5. Then, let's get the sum of each of the factor pairs. 1 plus negative 10 is negative 9. Negative 1 plus 10 is 9. 2 plus negative 5 is negative 3. Negative 2 plus 5, positive 3. Then, in this column, we look for the coefficient of x, which is negative 3, and it is here. This negative 3 points to the factor pair 2 and negative 5. This factor pair means m is the 2 and the n is negative 5. We substitute these values to our form here. So we have x plus 2 times x minus 5 equals 0. Now we equate each factor to 0 and solve for x. We have x plus 2 equals 0, x minus 5 equals 0. In the first equation, we transpose positive 2 to the right. So x equals negative 2. In the second equation, the negative 5 is transposed to the right. So x equals positive 5. These are now the roots or solutions of the quadratic equation. If we want to check if these values of x are correct, substitute these values in our original equation, and you will find out that this is satisfied. Example 3. Find two numbers whose sum is 27 and product is 182. Considering that sum is 27, we say that x equals the first number, and the second number is 27 minus x. Now, what about product is 182? We multiply the two expressions. So we have x times the quantity 27 minus x equals 182. We've simplified the left side. We have 27x minus x squared. This 182 we transpose to the left. Then we arrange the values. So we have negative x squared plus 27x minus 182 equals 0. Just to make this x squared to be positive, let's multiply this by negative 1. So we have now x squared minus 27x plus 182 equals 0. Now the constant 182 being positive means m and n, or the factors, must have same sign and similar to the sign of middle term. In this case, it is negative. Let us list all factor pairs of 182. Here they are, starting with negative 1 times negative 182, negative 2 times negative 91, negative 7 times negative 26, negative 13 times negative 14. Now let us get the sum of the factors. Now on this column, we look for the value of negative 27, and it is here. It points out to the factor pair negative 13 and negative 14. Therefore, we write x minus 13 times x minus 14 equals 0. Now we equate each factor to 0 and solve for x. So we have x minus 13 equals 0 and x minus 14 equals 0. In the first equation, x sub 1, or the first value of x, is positive 13. In the second equation, we have x sub 2, that is the second value of x, which is 14. Now let us check whether any one or both are correct. When first number x equals 13, the second number, which is 27 minus 13, equals 14. When first number x equals 14, the second number 27 minus 14 equals 13. Therefore, the two numbers whose sum is 27 and product is 182 are 13 and 14. Hi everyone. Today we're going to study solution of a quadratic equation by completing the square. Given a quadratic equation in standard form, ax squared plus bx plus c equals 0. Here are the steps for completing the square. Step 1. Divide ax squared plus bx plus c equals 0 by a. Take note that this a is the coefficient of x squared. The equation now becomes x squared plus b over a x plus c over a equals 0. Step 2. Transpose the constant to the right side. The c over a is the constant. It comes to the right, it becomes negative c over a. Step 3. Consider the special product x squared plus 2xy plus y squared. Supply the equivalent y squared of the left side values to complete the square. So that equivalent y square value is the b over 2a, that is power 2. Now let us analyze this value. It is simply this b over a here, the coefficient of x that we put here. But in the denominator, we multiply by 2. And then this b over 2a, we square it. And then, since we are adding this value to the left side, same value we must add to the right. Step 4. Factorize the left side and simplify the right side. The left side becomes x plus b over 2a with power 2. And the right side is equal to r. And this r is a constant. Now step 5. Take square root of both sides, then solve for x. Example 1. Solve the equation 2x squared minus 5x plus 3 equals 0 by completing the square. First, we copy our quadratic equation here. Next, we divide this equation by 2 because the coefficient of x squared is 2. We want the coefficient of x squared to be 1. So this equation now becomes x squared minus 5 over 2 x plus 3 over 2 equals 0. Then we transpose the constant to the right. The constant is the 3 over 2. It comes to the right as negative 3 over 2. Then we add the missing value to complete the square. On the left side, we add that 5 over 2 times 2. And this fraction is raised to 2. Same value we add to the right side. Then we simplify both sides. The left side we factorize as x minus 5 over 4 with power 2 equals, we simplify the right side as negative 3 over 2, and this now becomes 25 over 16. We add the two fractions now. Considering the LCD, the negative 3 over 2 becomes negative 24 over 16. Now we can simplify the right side as positive 1 over 16. Then we take the square root of both sides. We cancel the square on the left, and on the right we write plus or minus the square root of 1 over 16, which is simplified as plus or minus 1 over 4. Then we isolate x. The negative 5 over 4 we transpose to the right. We have now x equals 5 over 4 plus or minus 1 over 4. Now we split the values of x, one with a plus, the other with a minus. Let's begin with the plus, that is the x of 1. We have now 5 over 4 plus 1 over 4. This is equal to 6 over 4 or 3 over 2. Now the minus, that is our x of 2. We have 5 over 4 minus 1 over 4 equals 4 over 4 equals 1. These are now the values of the x. We call these solutions or roots. Example 2. Solve the equation 5x squared minus 6x minus 2 equals 0 by completing the square. First, we divide this equation by 5 because we want the x squared to be with coefficient 1. So the equation becomes x squared minus 6 over 5 times x minus 2 over 5 equals 0. Then we transpose the constant to the right. The constant is this negative 2 over 5. Now comes to the right as positive 2 over 5. Then we add the missing value to complete the square. The left side we add by the quantity 6 over 2 times 5. That is raised to power 2. And this same value we add to the right. Now we simplify both sides. The left side becomes x minus 6 over 10 with power 2 equals 2 over 5. Then we simplify this expression here as 36 over 100. Let us add the fractions on the right. Considering the LCD, the 2 over 5 becomes 40 over 100, then added to 36 over 100. The right side now becomes 76 over 100, and we can simplify this fraction further into 19 over 25. Now we take the square root of both sides. The left side becomes x minus 6 over 10 equals plus or minus the square root of the fraction 19 over 25. And we can simplify this square root of 19 over 25 as square root of 19 over 5. Then let us solve for x. This negative 6 over 10 we transpose to the right. So it becomes like this. The 6 over 10 from negative becomes positive to the right. Take note that the 6 over 10 can be simplified into 3 over 5. Then plus or minus the square root of 19 over 5. Let us show now the two values of x, one using the plus, the other using the minus. Let's begin with the first, x of 1 using the plus. So we have 3 over 5 plus square root of 19 over 5. We have here like fractions, so we can combine the numerators. So 3 plus square root of 19 over 5. This is the value of x of 1. What about x of 2? 3 over 5 minus square root of 19 over 5, which we can combine as 3 minus square root of 19 all over 5. These are now the two values of x. Again, we can call them roots or solution of the quadratic equation. Hi everyone. Today we're going to study derivation of quadratic formula. Given a quadratic equation in standard form, that is ax squared plus bx plus c equals 0. Let us now derive the quadratic formula. First, let us transpose the constant c to the right. From positive, it becomes negative. Next is, let us divide this equation by a, so that the coefficient of x squared here becomes 1. And if we divide it, the resulting equation is here. X squared plus b over a times x equals negative c over a. Let us complete the square of the left side. It means, considering the coefficient of x, the b of a, we are looking for a constant that is half of this b over a, and then we will square that value, just like this. So we are going to add this value to the left side and also to the right. And then let us simplify this square of 1/2 of b over a, and that is b squared over 4a squared. And then let us now factor out the left side to form a square of a binomial, while the right side we will simplify. The left side now becomes the square of the quantity x plus b over 2a. This is equal to, for the right side, first let us interchange the position of the terms. The b square over 4a square comes first. And then let us combine the two fractions of the right side. Obviously, the denominators are not the same. So let us manipulate the second fraction to make the denominators the same. Let us multiply the second fraction by 4a over 4a. If we do that, the denominator here becomes 4a squared, which is now equal to the denominator of the first fraction, while the numerator becomes c times 4a. So that is 4ac. So we can now combine the two fractions. The right side now becomes b squared minus 4ac all over 4a squared. The next step is to take the square root of both sides. And let us simplify this equation. For the left side, this big square root is cancelled out with that exponent 2. While the right side, we're going to distribute the square root to the numerator and to the denominator. This is now the resulting equation. We have x plus b over 2a equals plus or minus the square root of the quantity b squared minus 4ac all over the square root of 4a squared. Take note that the 4a squared in the radicand is a perfect square. We can simplify this expression into 2a. And then we will transpose the constant b over 2a to the right. So from positive, it becomes negative. And then let us combine the fractions of the right side. Obviously, they are like fractions. Simply, we operate in the corresponding numerators. So we have now x equals negative b plus or minus the square root of the quantity b squared minus 4ac all over 2a. This is now the beautiful quadratic formula. Let us see this example. Solve x squared plus 3x minus 10 equals 0 using quadratic formula. First, let us write the quadratic formula here. And then, let us collect the corresponding values for a, b, and c respectively. First, let us make sure that our problem is in standard form. And it is. Now, we are ready to collect the values for a, b, and c. The a is the coefficient of x squared, and that is equal to 1. b is the coefficient of x, which is positive 3. And c is the constant, and we write here negative 10. Next, let us substitute these values in our quadratic formula. So we have now x equals, the negative b is now negative of 3, plus or minus the big square root, b squared now becomes 3 squared, minus 4ac. and this is 4 times 1 times negative 10 all over 2a, and this is now 2 times 1. Simplifying further, we have now negative 3 plus or minus the big square root of the 3 square is now 9, and the product of negative 4 times 1 times negative 10 is positive 40. All over 2 times 1 is 2. Let us simplify this 9 plus 40. So we have 49. We know that this square root of 49 can be simplified into a whole number, which is 7. And from here, we're going to have two values of x. The first equation using the positive sign here, and the second equation using the negative sign. So the two values of x are x of 1 equals negative 3 plus 7 all over 2, and the x of 2 equals negative 3 minus 7 all over 2. For x sub 1, let us simplify this negative 3 plus 7 into 4, and this is over 2, and the quotient is 2. This is the first value of x. While the x sub 2, negative 3 minus 7 is negative 10, and we copy the 2 as denominator, and this quotient gives us negative 5. So the two values of x are 2 and negative 5. This is our final answer. Today we're going to solve quadratic equations by quadratic formula. First, let us define quadratic equations. Quadratic equations are of this standard form: ax squared plus bx plus c equals 0. But a should not be equal to 0. It means in a quadratic equation, there is a term with a variable raised to second power. Example, 2x squared plus 9x minus 5 equals 0. In here, our example is in standard form. All the terms are on the left side and it is equal to 0. Then we can collect the a, b, and c. Take note that the a is the coefficient of x squared. So a equals 2. The b is the coefficient of the x. So in here the b equals 9. And the c is the constant. So c is equal to negative 5. Do not forget the sign of the constant. Let us see now the quadratic formula. The solutions to a quadratic equation of the form ax squared plus bx plus c equals 0, where a is not equal to 0, are given by the formula, and this is the quadratic formula. X equals, in the numerator, is negative b plus or minus the square root of the quantity b squared minus 4ac all over 2a. Here are the steps on how to solve quadratic equation using quadratic formula. Step 1. Write the quadratic equation in standard form. Identify the a, b, and c values. Step 2. Write the quadratic formula. Then substitute the values of a, b, and c. Step 3. Simplify. Let us have some examples. This is example 1. Solve 2x squared plus 9x minus 5 equals 0 by quadratic formula. In solving, it means we want to get the values of the x. Step 1. Write the quadratic equation in standard form. The equation is already in standard form because all the terms are on the left and it is equal to 0. Identify now the a, b, and c values. So we will collect the a, that is the coefficient of x squared, it is 2. We collect now the b, the coefficient of x, and that is 9. And the c is the constant, negative 5. Step 2. Write the quadratic formula. Then substitute the values of a, b, and c. Here now is our quadratic formula. And then we substitute the values of a, b, and c. It is now the negative of b, and that is 9, plus or minus the square root of, this is now 9 squared, minus 4. The a is now changed into 2. The c is now negative 5 all over 2 times a, and the a is now changed into 2. And step 3, we will simplify and get the values for x. So the negative of the positive 9 is now negative 9, plus or minus 9 squared is 81. The product of negative 4, 2, and negative 5 is positive 40 all over 2 times 2 is 4. Then we simplify the radicand. The 81 plus 40 is 121. We just copy the negative 9, the plus or minus sign, and the denominator 4. On the next step, we need to simplify this square root of 121, and that is 11. Now at this point, we're going to split the plus and minus. There will be two values for the x. The x sub 1 is equal to, we will use first the plus sign. So negative 9 plus 11 all over 4. For the x sub 2, the negative sign will be used. So negative 9 minus 11 all over 4. Then let us simplify both. Negative 9 plus 11 equals positive 2 over 4. The negative 9 minus 11 equals negative 20 over 4. We can reduce to lowest term the 2 over 4. It is equal to 1/2. The negative 20 over 4 is equal to negative 5. So the two values of x are 1/2 and negative 5. Let's have example 2. Solve x squared minus 6x equals negative 5 by quadratic formula. Step 1. Let us write the equation in standard form. We can see here that the constant negative 5 is on the right. The standard form says the right side must be equal to 0. So we will transpose the negative 5 to the other side of the equation, and the sign must be changed. So the negative 5 becomes positive 5 on the left side, and it is equal now to 0. Then we will identify the a, b, and c. For our a, the coefficient of x squared is 1. The b, the coefficient of x is negative 6. And the c is the constant. Step 2, we go now to our quadratic formula. Then we will substitute the values of a, b, and c. So it's now negative of negative 6 plus or minus the square root of the square of negative 6 minus the constant 4 times a, which is now changed into 1, times c, which is now changed into 5, all over 2 times a, and a is 1. Step 3, let us simplify. The negative of negative 6 is positive 6, plus or minus the square root of the square of negative 6 is positive 36, minus the product of negative 4 times 1 times 5 is negative 20, all over 2. And then we will simplify the 36 minus 20. It is now 16. So our radical now is square root of 16. And then we can simplify the square root of 16 into 4. And from this point, we're going now to split the plus and minus sign to get the two values of x. X sub 1 equals 6 plus 4 all over 2, and x sub 2 equals 6 minus 4 all over 2. For the x sub 1, the 6 plus 4 is 10 over 2, which is equal to 5. For our x sub 2, the 6 minus 4 is 2 over 2, and that is equal to 1. And this is our final answer. Now let us consider example 3. Solve x squared equals 8x minus 16 by quadratic formula. Step 1. Let us write the quadratic equation in standard form. It means the 8x minus 16 we will transpose on the left side. If we do that, we should change the sign. Look at the 8x. It becomes negative 8x here, and the negative 16 on the right becomes positive 16, and it is now equal to 0. Then let us identify the a, b, and c values. A is the coefficient of x squared. It is equal to 1. B is the coefficient of x, and that is negative 8. And the c, the constant, positive 16. Then we will write the quadratic formula and substitute the values of a, b, and c. So this is now the negative of negative 8 plus or minus the big square root. The square of negative 8 is here, then minus 4 times a, which is now changed into 1, times c, which is now changed into 16, all over 2 times a, and is now changed into 1. Then step 3, we will simplify the formula. The negative of negative 8 is positive 8, plus or minus the square root of the square of negative 8 is positive 64. Then minus the product of 4 times 1 times 16. equals 64. All over, the 2 times 1 is 2. You see here we have 64 minus 64, and that is equal to 0. So our radical now is square root of 0, and when we simplify the square root of 0, it's simply 0. At this point, we will now split our x into plus or minus. The x of 1 is 8 plus 0 all over 2. 8 plus 0 is 8 over 2 is equal to 4. X of 2 is the 8 minus 0 all over 2. Also it is 8 over 2, and that is equal to 4. You see here our values are the same. It's like the solution of the quadratic equation is simply a single number, and that is 4. This is our final answer. Take note, in a quadratic equation, since the highest power is 2, the number of possible solutions is at most 2. Example 4. Find two consecutive odd positive integers, sum of whose squares is 290. We let x to be the first number. For the second number, we write x plus 2 because we require two consecutive odd positive integers. Then it says the sum of whose squares is 290. So we will square each of these numbers. So x squared plus the square of x plus 2, and that is equal to 290. Now let us simplify. Let us expand the x plus 2 with power square. So x squared plus 4x plus 4. Let us now combine x squared plus x squared. Then the 290 on the right, we will transpose to the left. So 2x squared plus 4x plus 4 minus 290 equals 0. Then we combine the numbers. 4 minus 290 is negative 286. We can simplify further this equation. Let us divide by 2. Then we have x squared plus 2x minus 143 equals 0. We can see that our equation here is now in standard form of quadratic equation. Then we will use the quadratic formula. Let us collect the values of a, b, and c respectively. So a equals 1, b equals 2, and c is the negative 143. We substitute these values to the formula. So we have x equals negative 2 plus or minus the big square root of 2 squared minus 4 times 1 times negative 143 all over 2 times 1. We simplify the radicand. The 2 squared will be 4. Negative 4 times 1 times negative 143 is positive 572. When added to 4, we have 576. Let us simplify the square root of 576, and that is 24. Now let us separate the values of x into two. One using the positive, the other is the negative. So x of 1 equals negative 2 plus 24 over 2. X of 2 equals negative 2 minus 24 over 2. Let us simplify x of 1 value. Negative 2 plus 24 is 22 positive over 2, and we will get 11. X of 2, negative 2 minus 24 over 2. The numerator becomes negative 26. Divide by 2, we have negative 13. In our problem, we require positive integers. Therefore, we only accept the positive 11 while we don't accept the negative 13. Therefore, our x is positive 11. This is our first number. So we write, when first number is 11, then second number is 11 plus 2 equals 13. So our numbers 11 and 13. Just to check, let us put 11 square plus 13 square. Is it equal to 290? 11 square is 121 plus 13 square is 169. When we simplify the left side, that is 290 equals to the value of the right. So this is our final answer. Today we're going to study discriminant. Let us define discriminant. In the quadratic formula, this is the quadratic formula, the quantity b squared minus 4ac. This is the radicand of the radical in the quadratic formula. That is called the discriminant. For a quadratic equation in standard form, ax squared plus bx plus c equals 0 and a is not equal to 0, we are going to use the discriminant to predict the number and nature of solutions of a quadratic equation. If the discriminant b squared minus 4ac is greater than 0, it means the discriminant is positive. The equation has two real numbers and distinct solutions. Or we can say that there are two answers, and these two answers are real numbers. If the discriminant is equal to 0, the equation has two real and equal solutions. In other words, we can say that there is one real solution. If the discriminant is less than 0, or we say that the discriminant is negative, the equation has no real solution. Let us determine the number of solutions to each quadratic equations. This is the first one. 3x squared plus 7x minus 9 equals 0. We're going to follow these three steps. First, let us write the quadratic equation in standard form. We can see here that the problem is already in standard form. Then we will identify the a, b, and c values. The a is the coefficient of x squared, and that is 3. The b is the coefficient of x, that is positive 7. And the c is the constant, it is negative 9. Next, we will write the discriminant formula, and we will substitute the a, b, and c values. So the b squared is now the square of 7 minus the constant 4 times a, which is now changed into 3, times the c, which is now changed into negative 9. Then we will simplify. The 7 squared is 49 minus the product of 4 and 3 and negative 9. So the answer is positive 108. Then 49 plus 108 is 157, and this is a positive number. Since the value of discriminant is positive, there are two distinct real solutions to the equation. Let's have example 2. 9x squared plus 1 equals 6x. First, let us write the quadratic equation in standard form. So this positive 6x on the right side of the equation is transposed to the left side, and the sign is changed. It is now negative 6x, and the right side is now equal to 0. Then we will collect the a, b, and c values. The a is the coefficient of x squared, that is 9. The b is the coefficient of x, that is negative 6. The c is the constant, positive 1. Then we will write the discriminant formula and substitute now the values of a, b, and c. The b squared is now the square of negative 6 minus the constant 4 times a, which is now changed into 9, times the c, and now change into 1. Then we simplify further. The square of negative 6 is positive 36 minus the product of 4 and 9 and 1 is 36. So we have 36 minus 36 equals 0. Since the value of discriminant is 0, the solutions are equal, or we can say there is one real solution. Let us have example 3. The monomial x times the binomial 5x plus 1 equals negative 4. First, let us write the quadratic equation in standard form. The x here will be multiplied to each term of the binomial. So we have the x times 5x is 5x squared plus x times 1 is x, and then the negative 4 on the right side is transposed on the left. The sign will be changed. From negative, it becomes positive, and this is equal to 0. Then we will identify the a, b, and c values. The a is the coefficient of x squared, that is 5. The b is the coefficient of x, and that is 1. And the c is the constant, positive 4. Then on the discriminant formula, we will substitute the values. The b squared is now the square of 1 minus the constant 4 times a. The a is changed into 5 times c. The c is now changed into 4. Then we will simplify further. 1 squared is 1 minus the product of 4 and 5 and 4, that is equal to 80. 1 minus 80 is negative 79. Since the value of discriminant is negative, there is no real solution to the equation. Today we're going to study applications of quadratic equations. When we say applications, we refer to word problem. So how to solve word problem involving a quadratic equation? We have here 5 steps. Step 1. Read the problem and identify what is required. Step 2. Represent the required as a variable and translate the condition into an equation. Step 3. Solve the equation. Step 4. Check the answer if it satisfies the condition of the problem. Step 5. Write the answer in a sentence. Let us have example 1. The product of two consecutive odd integers is 195. Find the integers. In step 1, let us read the problem and identify what is required. In here, the required is two consecutive odd integers. As an example of consecutive odd integers, here we have 5 and 7. Both are odd integers and they are consecutive. In step 2, let us represent the required as a variable and translate the condition into an equation. We let n to be the first odd integer, and then the n plus 2 to be the second odd integer. If you look at our example of consecutive odd integers, the gap between the first odd integer, 5, and the second odd integer, 7, is 2. That is why, with respect to the first odd integer, we write here n plus 2 to represent the second odd integer. Now, the problem says the product of the two numbers, so we are going to multiply the first odd integer n times the second odd integer n plus 2, and this is equal to the product 195. And step 3, we will solve the equation. So the n will be multiplied to the binomial n plus 2. So n times n will be n squared. N times the 2 is positive 2n. The 195 on the right side is transposed on the left side, and the sign is changed. From positive on the right, it becomes negative now when transposed on the left, and this is now equal to 0. Our equation now is in standard form of a quadratic equation. Now we will write the quadratic formula, but this is about x. Since our variable used here is n, we can change the x into n. And then we will collect the corresponding a, b, and c values. The a is the coefficient of n squared, and that is 1. The b is the coefficient of the n, that is positive 2. And the constant c is negative 195. Then we will substitute these three values. So this is now negative of the b, and that is 2, plus or minus the big square root. The b square is now the square of 2 minus the constant 4 times a, and it's now changed into 1. Then times c, and the c is changed into negative 195 all over 2a, 2 times 1. Then we will simplify further. The negative of this value 2 is now negative 2 plus or minus the big square root. 2 square is 4. And then this negative 4 times 1 times negative 195 equals positive 780. All over 2 times 1 is 2. And then 4 plus 780 will be 784. This is square root of 784 can be simplified, and that is 28. And from this point, we are going to split the plus and minus sign. So we will have two values for n. The n sub 1, and that is negative 2 plus the 28 all over 2. And the n sub 2, now using the negative sign. Negative 2 minus 28 all over 2. To simplify n sub 1, this negative 2 plus 28 equals 26 over 2, and this is equal to 13. For the n sub 2, the negative 2 minus 28 is negative 30 all over 2 equals negative 15. Take note that the n sub 1 and n sub 2 both represent the first odd integer. Thus, there are two possible answers. The answer 1, when we have the n sub 1 here as equal to 13, that is the first odd integer, we can compute the second odd integer using our n plus 2, and that is equal to 15. So our first answer, 13 and 15. For answer number 2, we will use the n sub 2. The value is negative 15. That is the first odd integer. So the second odd integer will be n plus 2, and that is negative 15 plus positive 2, that is equal to negative 13. So the second answer, the second pair is negative 15 and negative 13. For step 4, let us check the answer if it satisfies the condition of the problem. For the answer number 1, the first pair is 13 and 15. Both are odd integers and they are consecutive. If we multiply 13 and 15, we will get positive 195. So answer 1 is correct. For answer number 2, our answer here is negative 15 and negative 13. Both are odd integers and they are consecutive. If we multiply negative 15 times negative 13, the product is positive 195. So this answer here satisfies the condition of the problem. So both answers are correct. So step 5, we're going to write the answer in a sentence. So this is the answer. The two consecutive odd integers whose product is 195 are 13, 15, and negative 13, negative 15. And this is our final answer. Let us have example 2. A rectangular garden has an area 15 square feet. The length of the garden is 2 feet more than the width. Find the length and width of the garden. In step 1, we read the problem and identify what is required. In here, the required is the length and width of the garden. Step 2, we will represent the required as a variable and translate the condition into an equation. For geometry problem like this, we will draw the figure. The problem is about a rectangular garden. So we have a rectangle here, and we will assign values: L for the length of the garden, W for the width of the garden. Next, the area of this rectangular garden is length times width. Another condition of the problem is the length of the garden is 2 feet more than the width. So our equation here, we write L equals W plus 2. Area of the rectangular garden is 15 square feet. So we put here area equals 15. We will use the formula A equals L times W. Then we will substitute the values. The value of A, or the area, is 15. So we change that A into 15. The L is equal to the W plus 2. We will substitute this value for the L. And then times the W, we copy the W here. And step 3, we will solve the equation. Means this W I am going to multiply to the binomial W plus 2. So W times W is W square, and W times 2 is positive 2W. The 15, we transpose it, the sign will change into negative 15. So in here, it is now in standard form of a quadratic equation. But since we are familiar that the 0 is on the right, we can just simply interchange the right side and the left side. There is no issue on that. The next is, we're going to write our quadratic formula. Since we're using the variable W, we will put here W. Then we will collect the values of A, B, and C. The A is the coefficient of W square, that is 1. The B is the coefficient of the W here, and that is 2. And the C is the constant, negative 15. Using these values and substitute to our quadratic formula, the negative of B is now the negative of 2 plus or minus the big square root. The B square is now 2 square minus constant 4 times A. A is now changed into 1 times C. The C is equal to negative 15. Then all over 2A. 2 times 1. Then we will continue to simplify. This negative of 2 is now negative 2 plus or minus the square root of 2 square is 2. Then we multiply negative 4 times 1 times negative 15. We will have this positive 60. All over 2 times 1 is 2. Then 4 plus 60, we can simplify this further into 64. And we know that the square root of 64 can be simplified into 8. At this point, we are now to split the plus and minus in here. We have the W sub 1 and W sub 2. For W sub 1, we will use the positive sign. So negative 2 plus 8 over 2. For the W sub 2, we will use the negative sign. Negative 2 minus 8 over 2. And we will simplify further. For the W sub 1, negative 2 plus 8 is positive 6 over 2. And this is equal to positive 3. For the W sub 2, negative 2 minus 8 is negative 10 all over 2, and this is equal to negative 5. Take note that our W sub 1 and W sub 2 represent the width, this width of the garden. However, width cannot be negative. So from here, the value of negative 5 is not acceptable. So we will only consider the value of width as positive 3. It means our answer is positive 3, and for the length, we will just use our relation that W plus 2, and that is equal to 5. We don't forget to write the unit. The width is 3 feet, the length is 5 feet. Now for step 4, we will check the answer if it satisfies the condition of the problem. It says here the garden has an area of 15 square feet. Our formula for the area is length times width. If I multiply the width, the number 3, times the length, which is 5, it is equal to 15 square feet. The first condition here is met. The second condition, the length of the garden is 2 feet more than the width. The length is 5 feet, the width is 3 feet, so the length is 2 feet more than the width. The second condition here is also satisfied. So step 5, we will simply write the answer in a sentence. The length and width of the garden is 5 feet and 3 feet respectively. This is our final answer. I hope you learned something from this video. See you again next time.